The modernization of the French Army's engineering capabilities has taken a significant step forward with the development of the Engin du Génie de Combat (EGC). As part of the Scorpion program, this next-generation armored engineering vehicle is set to replace outdated platforms and enhance battlefield efficiency. Initially known as the Moyen d'appui au contact (MAC), the EGC has undergone refinements to better align with operational requirements, ensuring a more robust and adaptable system for military engineers. The current engineering vehicle in service, the Engin du Génie (EBG), has been in use since 1989 and is based on the AMX-30B2 chassis. Despite modernization efforts over the years, a more advanced solution is required to meet modern combat demands. The EGC will replace not only the EBG but also the Engin du Génie Rapide de Protection (EGRAP) and the Engin du Génie d'Aménagement (EGAME), providing a comprehensive upgrade to the Army's engineering capabilities. Belgium has also joined the initiative under the CAMO, Capacité Motorisée, partnership, planning to replace its Pioneer vehicles with the EGC. According to France's Military Programming Law, LPM, for 2024 to 2030, the Army was initially set to receive 5 EGC units before 2030, with 125 total units planned by 2035. However, a recent review by the Organisation Conjointe de Coopération en Matière d'Armement, OCCAR, has pushed the first deliveries to 2031, with a total production goal of 200 units by 2040. Belgium has expressed the need for approximately 30 vehicles. The estimated budget for the project, covering development, production, and initial logistical support, is projected to be between €800 million and €1.2 billion. The procurement process, managed by OCCAR, is set to be competitive, restricted to suppliers from OCCAR member states and the European Union. A market consultation is currently underway, with an industry day scheduled for May 14, 2025, in Bonn, Germany, where interested suppliers will receive further details. Companies seeking participation must submit their applications and capability statements by April 4, 2025. The development plan follows a phased approach, including a System Requirements Review, SRR, Preliminary Design Review, PDR, Critical Design Review, CDR, Test Readiness Review, TRR, and Qualification Review, QR. Prototype testing is expected between 2028 and 2029, with full qualification by 2030. The EGC's technical specifications highlight its advanced engineering and combat capabilities. The vehicle must feature an interchangeable excavator arm and bucket capable of digging tank positions within 50 minutes and constructing anti-tank ditches at a rate of 30 meters per hour when 2 units operate together. It will also be capable of lifting 3-ton loads, creating trenches up to 2.5 meters deep, and forming protective earth berms. Operational both day and night, the EGC will be equipped with enhanced visibility systems to ensure efficiency in all conditions. Additionally, the vehicle must be road certified for use in allied nations. Beyond engineering tasks, the EGC will integrate seamlessly with the Scorpion combat system. It will be equipped with advanced communication tools, including contact/synapse radios, the SICS Battlefield Management System, and the Barrage Electronic Warfare Jammer. The vehicle must match the operational capabilities of the Griffin and Jaguar armored platforms, ensuring continuity in mobility, protection, and off-road performance. Designed for diverse environments, from muddy terrains to sandy landscapes, the EGC will feature an adaptive tire pressure system for enhanced traction and a winch for self-recovery. Its 3-person crew, comprising a commander, driver, and radio gunner, will operate the vehicle, which is also designed for compatibility with chemical, biological, radiological, and nuclear (CBRN) protective measures. One of the most notable contenders for the EGC contract is CNIM, a French company that has presented both an initial prototype and an evolved concept. Originally introduced in 2022 in collaboration with Texelis, the EGC was envisioned as a highly mobile 8x8-wheeled engineering vehicle tailored for modern battlefield demands. Designed to perform a range of engineering tasks, from clearing obstacles to fortification construction, it is built with crew protection as a priority. Furthermore, its seamless integration into the Scorpion system ensures interoperability with other armored units deployed by France and Belgium. A major advancement in the EGC's evolution is the introduction of the Ora concept by the CNIM Systèmes Industriels, KNDS France, and Texelis Consortium. Initially designed with a more complex architecture, the Ora has since been refined into a more streamlined system, featuring a forward-mounted arm that can support either an excavator bucket or a loader. The vehicle, based on an 8x8 chassis derived from Singapore's Turex armored vehicle, weighs 28.6 tons and includes advanced optronic systems for enhanced situational awareness. It is armed with a remotely operated 7.62mm turret for self-defense. Powered by a 600 horsepower diesel engine, it reaches speeds of up to 80 km per hour on roads and has an operational range of 600 km. Engineered for both combat support and disaster response, the Ora concept is equipped to handle complex terrain modifications and obstacle removal. As development progresses, the EGC is expected to become a cornerstone of France's military engineering strategy, reinforcing its operational flexibility and technological edge. With refined designs, robust capabilities, and a commitment to interoperability, the next-generation engineering vehicle will play a crucial role in future military operations, ensuring that both French and Belgian forces are prepared for the evolving challenges of modern warfare.